equivalent fractions and lowest terms. Fractions that represent the same amount of the whole are called equivalent fractions. We're going to start by shading in half of the total number of squares in this chart. All right. So now that that's done, I want to express this value as three different fractions. Well, I know I've shaded in half of them, so that's going to be the first fraction, 1 over 2. I'm also going to express this maybe in terms of the number of columns. So I want to think about how many columns did I shade in? I shaded in 1, 2, 3, 4, 5, and I had 6, 7, 8, 9, 10 columns in total. I may also want to think about this in terms of how many individual squares I shaded in. So I shaded in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I shaded in 25 squares out of 50. So that could be another fraction. You could have also have thought about this in terms of, well, how many squares did I shade in, right? So how many, if I was to create groups of 4, how many would I shade in? There's lots of different ways that you could have come up with your fractions, but these are 3 equivalent fractions based on what I've shaded in here. So what you want to do now is we want to think about, well, what does this mean? So I've shaded in this diagram. I've come up with different ways that I could express this, how many squares that I've shaded in. Now what? Well, we need to think about how we can get from this smaller fraction to these larger fractions. So larger equivalent fractions can be formed by multiplying this numerator and the denominator by the same value. So if we were looking here, in order for me to go from 1 to 5, I needed to multiply this by 5. The same thing happens with my denominator. 2 times 5 gives me 10. I can also think about, what did I have to do in order to make my 2 a 50? Well, I had to multiply that by 25. And 1 times 25 is also 25. So that's important to note as well. So I can make fractions that are larger equivalent fractions by multiplying the numerator, so the top and the bottom, by the same value. So let's state 2 larger fractions of the fraction 3 over 5. Well, maybe I want to multiply it by 2 to begin with. So 3 times 2 gives me 6, and 5 times 2 gives me 10. That's one way. Maybe I want to multiply it by 3. So then I get 3 times 3, which is 9, and 5 times 3, which is 15. I could even go further, and I could maybe multiply it by 5. So 3 times 5 is 15, and 5 times 5 is 25. And you could multiply by any constant that you wanted to in order to create larger equivalent fractions, from 2 all the way to even 1,000 if you wanted to think about it like that. We can use the concept of equivalent fractions to come up with missing values in our sets of equivalent fractions. So later on, this is going to be what we're going to be looking at in terms of algebra or even ratios and proportions. So the same sort of strategy or the concept will be explored again in a different manner. Well, so let's think about what we have to multiply 7 by in order to get to 35. So 7 times 35, or 7 times 5, is equal to 35. So in order to find this missing value, I must also have to multiply my numerator by 5. And 4 times 5 is 20. What if I was going in this opposite operation? What if I wanted to figure out how do I go from 48 to 8? Well, because I'm going from a larger number to a smaller number, instead of multiplying, I'm going to divide. So if I remember my times tables, if that was something that you worked on in elementary school, you might remember that 48 divided by 6 will give you 8. So what number, maybe, would I need to figure out that way? So that's one way that you could figure that out. And then you could say, okay, what number divided by 6 gives me 5? And you might say, that's 30, because 30 divided by 6 gives me 5. So that's one way to think about it. So you can either think about it in terms of multiplication or from bigger to smaller, which is division. What number do you have to multiply 6 by in order to get 42? Again, looking at those multiplication tables, you hopefully would remember that it's 7, and 11 times 7 is 77. So that is the missing denominator for part C. And lastly, for D, you have to multiply 4 by 9 to get 36, and 12 times 9. Those 12 timetables tend to always be the hardest to remember, but it's 108. All right. So just like finding larger equivalent fractions can be formed by multiplying, reducing equivalent fractions can be formed by dividing the numerator and denominator of a fraction by the same value. So now let's state some smaller equivalent fractions. So I'm going to choose a number that I can divide both my numerator and my denominator by evenly. So it's not as easy as just picking any random number. We want to find a number that will give me whole numbers because I don't want decimal numbers in my fractions. So I might say, hey, both of these end in a 0, so I bet you I could divide those by 10. So 20 divided by 10 is 2. And 30 divided by 10 is 3. So that's 1. I may also say to myself, hey, because they end in zeros, they're both multiples of 5, so I could divide both my numerator and my denominator by 5. So then that would become 20 divided by 5 is 4, and 30 divided by 5 is 6. And then you may also say to yourself, these are both even numbers, so I could divide them both by 2's. So this becomes 20 divided by 2, which is 10, and 30 divided by 2, which is 15. So knowing those multiplication tables come in very handy when we're looking at trying to solve for equivalent fractions. So let's use that strategy now to come up with our other values. So remember I said you could either, when we're going from a larger number to a smaller number, we can think about dividing. And if we're going from a smaller number to a larger number, we can think about multiplying. So 25 divided by 5 is 5. So I have to divide my numerator by 5 as well. And 15 divided by 5 is 3. For part B, 24 divided by 3 gives me 8. And 21 divided by 3 gives me 7. That's my missing numerator. For part C, 32 divided by 4 gives me 8. So 44 divided by 4 gives me 11, and that's my missing denominator. And lastly, 16 divided by 2, or 16, sorry, divided by 8 is 2, and 56 divided by 8 is 7, so that's my missing denominator. So when fractions are made smaller, this is also referred to as reducing the fraction. And when we get further on in our fractions, I would want all of your final answers when we're dealing with fractions to be in lowest terms. So a fraction is considered to be in lowest terms if it does not contain any shared factors except 1. So there is nothing that we can divide 7 and 8 by other than 1. So there's nothing that will divide evenly into both of those numbers. That's in lowest terms. So we're going to write each of these fractions in lowest terms. So sometimes you can do this in one step. Sometimes you might have to take multiple steps depending on how confident you are in your multiplication tables. So I always challenge you to think about whether these numbers are even or odd. If they are both even, you can always divide by 2. So if you are stuck on figuring out those multiplication tables or trying to figure out what number will divide evenly into those, always say if they're both even numbers, I can divide those by 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4. And then from there, ask yourself, is there a number that will divide evenly into both 3 and 4? The answer in this case is no, so this is in lowest terms. When you are dealing with larger numbers, you can still ask yourself, are these both even numbers? And you could say yes, so I could divide these both by 2's. And that would give me 12, because 24 divided by 2 is 12, and 96 divided by 2 is 48. And then ask yourself, is there a number that will divide evenly into both of these again? And the answer would be yes, and that answer is 2 again because these are both even numbers. So if you need to take multiple steps, then take those multiple steps. No one says you have to do this in one step. So 12 divided by 2 is 6, and 48 divided by 2 is 24. And then you ask yourself, is there a number that will divide evenly into 6 and 24? And the answer would be yes, and these are both even numbers, so I can divide them both by 2. So 6 divided by 2 is 3, and 24 divided by 2 is 12. And then lastly, ask yourself, is there a number that will divide evenly into 3 and 12? And again, the answer should be yes, and that answer is 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4, and that is finally in lowest terms. So if you need to take multiple steps, then take those multiple steps. If you can figure out what a larger number is, you can do that as well. So maybe you know that both of these numbers could be divisible by 12 to begin with, and then you could take shorter steps. Or maybe you already know what the largest number is that will divide evenly into both of those, being 24. And so that would be helpful as well. So you could do this in one step by knowing that I can divide both my numerator and my denominator by 24. 24 divided by 4 is 1, and 96 divided by 24 is 4, and that's in lowest terms. So if you can do it in one step, do it in one step. If you need to take multiple steps, then that's fine as well. So part C, 225 over 400, those are both multiples of 5. So I'm going to start by dividing both of these numbers by 5. So 225 divided by 5 is 45. And 400 divided by 5 is 80. Again, these are both multiples of 5, so I'm going to divide by 5 again. 45 divided by 5 is 9, and 80 divided by 5 is 16. And then you could ask yourself, was there anything else? Well, they're not multiples of 5, so I can't divide by 5s. They're not even numbers, because the 9 is not an even number, so I can't divide that. Then I can go to 3, because 9 divides by 3, but 16 doesn't. And so there's nothing else that I can divide both my numerator and my denominator by to get nice whole numbers. So this is indeed in lowest terms. If you have any questions about this lesson, please send me an email or sign up for a virtual help session, and I will see you in the next lesson.